Hey everyone, welcome back to my YouTube channel, and in this video we are going to discuss one more problem on backtracking, and this problem is actually based on trees. Okay, so let's try to understand what exactly is the problem statement. After that we'll solve this question. So the problem is you'll be given a tree like this is a tree, and along with this tree one more thing will also be given, that is the value of k, right? And what you need to do, you need to find out the path from root to k. Okay, this you need to find out the path from root node to k. So let's say the value of k is 8 in this case. 8 is here, and this is our root node, correct? So the path will be 7, then we have 2, then 8. This will be the path, right? 7, 2 and 8. Let's say the value of k is 5. Here in this case the path will be 7, then 4, and then 5. This will be the path. So you need to print this path according to the value of k, correct? Now let's try to figure out that how we can solve this problem with the help of recursion and backtracking. So here I've created a function, and in this function there are three parameters. The first one is the root node, second is the value of k, and the third one is the vector in which we'll be storing these paths. So let's say the value of k is 8 in this case, okay? And here I have written 1 to 3 on all of these nodes. So 1 to 3 is nothing but these are the steps that we need to execute for each and every nodes in this tree. Step number 1 is this, which is just to visit the left hand child of the node. This is step number 2, which is to visit the right hand child. And in step number 3 we are just popping out the last element from the vector. Okay, so these are the three steps that we need to execute for each of these nodes, correct? And let me create a vector here, which is v, and now let's run this code on this tree. Okay, so we just need to pass the root node to this function, and the first condition is we just need to check whether the value of root is null or not. So it is not null, so we'll not execute this if condition. And in the second step we are just pushing the root of data into this vector. So root of data is 7, we just need to push 7 here. Okay, in the third step we are just checking whether root of data is equal to k or not. So the value of k is 8, root of data is 7, so these two values are not equal. Will not execute this if condition. Again, at the next step we just need to move to its left hand child. So let's move to its left hand child, and this is actually step number 1. Step number 1 is completed for node number 7, correct? Since it is recursion, so we are back to starting point of this function. Okay, now again same steps, root is not null. Okay, and here we are just pushing the root node inside this vector. So let's push 2 here. Again here we are just checking whether the root of data is equal to k or not. So it is not equal because the value of k is 8. And now move to its left hand child. So step 1 is completed for this node. Now we are back to this step, root is not null. Let's push 6 here. It is not equal to k, and let's move to its left hand child. Step 1 is completed. Now left hand child is actually null. Okay, so here root is null, so we'll return false to its parent node. So let's return false. Okay, this value is actually false for node number 6. Step 1 is completed. Now we need to execute step number 2 and 3. So in second step we just need to visit its right hand child. Okay, so let's visit its right hand child, which is again null, and from here also you'll get false value. Okay, because if root is null we just need to return false. So step 1 is returning false, as well as step 2 is returning false, correct? So these two values are false, and since these two values are false we will not execute this if condition, right? Now in the third step we need to pop out the last element from the vector. So the last element is 6. Now let's pop out 6 from this vector. Okay, so all the three steps are completed for node number 6, and here at last we need to return false to its parent node. So let's return false. Now for node number 2, the left hand child means this value is false. Okay, and step 1 is completed for node number 2. Now we need to execute step number 2 and 3. So in second step we just need to move to its right hand child. Step 2 is completed. Now we are at node number 8. Okay, now let's execute all these things for node number 8. So root is not null. Again we need to push root of data, that is 8, into this vector, correct? And here you can see that root of data is equal to k. The values are equal, right? So in that case we need to return true to its parent node. So this is true. Now for node number 2, this value is false, okay, because from left hand side we are getting false, and this value is actually true, okay. So overall the value is true because here we have OR condition, and since this is true we just need to return true to its parent node. So this is true. Now for node number 7, the left hand side is true. Now we need to execute the right hand child, okay. So let's move to its right hand child, and we need to perform all the similar steps for these nodes, right? You got the idea. And this is how we can print the path from root to any of the k value, correct? And here is the code for it. I'll upload the code on my GitHub. You can find out the link in the description box, okay. So that's it for this video. Thank you.